Good morning, Chairman and all committees. Today we are going to talk about our project. Our project name is IoT-based Building Movement Monitoring System. And today there are four topics to talk about today. First, let me introduce you about our project. Building and structure are moving all the time, but usually these movements are really small as to be unnoticeable without a proper measurement equipment. It occurs with many reasons such as thermal expansion with survey, seismic activity, different rate of settlement. It directly damages our structural stability and lead to many serious problems. And the worst is a building collapse. In our day, there are many methods to measure the building movement using global positioning system, or we also know as GPS, is one of the techniques. But this technique has a disadvantage, which is the unstable of the data. So our group come up with a question: can other device monitoring behavior of building movement instead? The objective of this project is to invent the prototype of building movement utility to detect the movement of structure by adapting gyroscope sensor with an Arduino board and to check and evaluate the accuracy of precision of an invention.
Our prototype device will consist of three hardware. The first one is Node MCU ESP8266, which will act as a hub for calculating and communicating between each microcontroller. The other two is the sensor. The first one is gyroscope sensor. The gyroscope sensor will measure the change in angle in three axes, and the real-time clock will measure the time without need of electricity. These two sensors will send the data back to Node MCU. The device will be attached to the frame model. In this figure, it shows the front view and side view of the frame model and also the corresponding axis. However, our frame model can only rotate it around y-axis. So in this experiment, we will focus only on y-axis. For the flowchart of the system, starting from gyroscope sensor and the time sensor, the gyroscope sensor will measure the change in angle, and the time sensor will measure the time and send that data into ESP8266. The change in angle will be calculated into displacement and compressed together with time data into JSON format to be sent through the Wi-Fi network into Google Cloud Platform system. The programming language we use is C++ on Arduino IDE and the JavaScript on script editor to receive the data from the device.
For result and discussion. First one is calibration. Before to do the experiment, we must calibrate the gyroscope sensor because the error occurs by the imperfect of gyroscope sensor installation, and the error will lead to an incorrect of further measurement and displacement calculation. The calibration will help gyroscope sensor to obtain the most accurate reading angle data and calculation displacement data by eliminating the occur error. In Figure 1 and Figure 2, show the obtained measurement angle and displacement data of y-axis. As you can see in those two figures, the black line is the average data before calibration, which is not close to 0. And for the red line is the average data of after calibration, which is close to 0. And this table shows the average value from each category. For the x-axis, the rotation angle data before calibration is equal to minus 0.74 degrees, and it can be calculated into displacement equal to minus 0.15 centimeter. After calibration, the rotation angle is equal to plus 0.01 degree, and it can be calculated into displacement equal to 0. For the y-axis, the rotation angle data before calibration is equal to plus 2.11 degree, and it can be calculated into displacement equal to plus 0.44 centimeter. After calibration, the rotation angle is equal to minus 0.02 degree, and it can be calculated into displacement equal to 0. Without calibration process, the error will be occur 0.15 centimeter for x-axis and 0.44 centimeter for y-axis. The equipment is unacceptable to be used as measurement equipment. And after we calibrate the sensors, there are 5 experiments. First is displacement accuracy. In order to know the accuracy of sensor, we compare and calculate displacement with dial gauge, and we are only focusing on y-axis. In Figure 3, the black line is a trend line show the displacement data from gyroscope sensor of y-axis, and the red line show the displacement from dial gauge reading. The black line is following to the red line in the same trend. The differential of calculate displacement from gyroscope sensor and displacement measure for dial gauge is equal to plus 0.01 meter for y-axis. So this device is accurate enough to monitoring the behavior of building movement. For the range of error, it calculates displacement data from gyroscope sensor, deliver at maximum and minimum of differential of calculate displacement between gyroscope sensor and dial gauge reading. The purpose is to find the range of error that gyroscope can measure. And we can set to displacement to fix at 1.1 centimeter. So from these two figures, the maximum range of error is equal to plus 0.13 centimeter, and the minimum range of error is equal to minus 0.12 centimeter. So it can be round up into minus 0.15 to plus 0.15 centimeter. With this range of error, the device is able to measure the movement of building and structure.
For the variance of data from multiple gyroscope sensor, in order to check the variance of calculate displacement data from two or more gyroscope sensor, in this experiment, two gyroscope sensors were used in the experiment. Both gyroscope sensor was named as a connected port, which is COM3 and COM6 gyroscope sensor. Both of gyroscope sensor was tested at the same time on the same model. The calculated displacement of both gyroscope sensors should be equal or close to each other. The purpose of this experiment is to simulate the system of gyroscope sensor. When the equipment is stored into a real structure, each column in the structure requires one gyroscope sensor to deliver the most accuracy of displacement of a building, which means that in the building there are two or more gyroscope sensors. As you can see, the black line is the trend line of the COM6 gyroscope sensor displacement, and the red line is the trend line of the displacement from COM3 gyroscope sensor. Both two trend lines are going in the same direction. So after calculate the differential of displacement from COM3 and COM6 gyroscope sensor, as you can see in figure 8, the average of the differential is equal to 0.01 centimeter for the gyroscope sensor run. The purpose of the experiment is to check the durability of an equipment. In this experiment, the gyroscope sensor was run for 7,800 minutes. After the experiment, the gyroscope sensor can measure and calculate the data for a long time, which can be concluded that the equipment will be durable enough to be used in a real structure for a long time. With this reason, the equipment will collect and calculate the data continuously. The data will be more accurate without the repayment of equipment during the usage of a device.
The last experiment is the online result real-time monitoring. As you can see in figure 11, this is the online result monitoring shown in the Google Sheet. The data will be divided into three columns. The first one is displacement in x-axis, and the next one is in y-axis, and the last one is the time that the data was collected. The data can also be shown in the relationship between displacement and time, and you can see in the right-hand side of the figure. For the conclusion and recommendation regard to our objective, we can conclude that after all of 5 experiments, data were collected, analyzed, and discussed. All of the requirements of this system and device are passed regarding to accuracy, precision, and monitoring. The device has fully fulfilled the purpose of this research in both terms of detecting building movement and create database online by using the wireless communication. And our recommendation for improving the project, the prototype frame model should be redesigned to be able to rotate in x-axis and z-axis also. And the installation of sensors in Arduino should be also careful about the response to data collection. The connection of sensor and Wi-Fi should be more stable to keep the data running smoothly in real time. And the data receiver can develop into a data website that can be accessed to more stable form. And the last one is the low pass filter function should be improved for greater accuracy.